This is the 4-8 to 4-10 review. Calculators are not allowed. Number 1. For each of these functions, we are given the derivative, and the question is to find the function whose graph passes through the specified point. So if we look at part A, we need to ask ourselves, what did I take the derivative of that gave me a 2x? And the answer would be move through the constant, add 1 to the power, and divide by the new power. Do the same thing here. Move through the constant. The current power is x to the 0, so we will add 1 and divide by the new power, and then add a constant. Because remember, when we take the antiderivative, we get an entire family of curves. So the reason we were given this point was so that we could nail down the c. So before we use this point, I'm going to simplify what I have here. So I will get f is an x squared plus a 4x plus a c. Now we know that when I plug 2 in, I should get a 15 out. That means a 15 will come out when I plug a 2 in. Solving for c, I have 15 equals a 4 plus an 8, which is a 12, so that means c is going to be 3. And my final answer is f of x equals an x squared plus a 4x plus a 3. B works the same way, only this time we have to do antiderivatives of an exponential. So f in this case, we will again move through the constant. And remember that e's, when we take derivatives, are the same thing. So when we go backwards, we're going to get the same thing. And then we have to do the chain rule backwards. So normally if I were going forward and I were taking the derivative, I would be multiplying by a 0.6. Because I'm going backwards and getting the antiderivative, I'm going to divide by that 0.6. This one is a power rule backwards, so I'll move through the constant, add 1 to the power, and divide by the new power. And again, I'll need to add a constant at the end so that I represent the entire family of antiderivatives. Simplifying this, I get f of x equals e to the 0.6x plus a 2x squared plus a c. Now we're ready to use our point, which is when I plug 0 in, I get a 5 out. So if I plug in 0, I'll get a 1 plus a 0 plus a c. So that means my c is 4. So my final answer, f of x, will be e to the 0.6x plus 2x squared plus 4. Final part, C. To find the antiderivative, we need to ask, what did I take the derivative of that gave me this? So we'll again move through the constant. What do we take derivatives of that generate a sine? Well, that is a cosine negative of the inside unchanged. And then we have to think about doing the chain rule backwards because we have something other than an x inside. So normally going forward, I would multiply by a 3 pi. Because I'm going backwards, I'm going to divide by that 3 pi. For the next one, what is it that I take the derivative of that gives me a 1 over x? Well, that's a log natural of an absolute value of x. And again, I need to add my c. So the question is, when I plug 1 in, I should get a 12 out. So I'll get a 12 out when I plug in a 1. Log natural of 1 is 0. Cosine of 3 pi is going to be a negative 1, so we get a 12 equals a positive 2 over 3 pi plus c, which means c will equal a 12 minus a 2 over 3 pi. And my function will be y equals a negative 2 over 3 pi cosine of 3 pi x minus log natural of the absolute value of x plus 12 minus 2 over 3 pi. Plug that c back in, and we're done.